right, so I think I've got a good strategy for you. So we'll do the other trig functions today. Do a little bit more practice on Tuesday, which will be tomorrow. And then I think we got to do tests on Wednesday and Thursday. What else do you guys have going on this week?
We can get through all the functions.
They're so easy.
The rest of them in one day.
Yep.
Are they?
The other took us like a week each.
I know. But they're so easy.
Are you sure?
They better be
Positive.
straight lines.
Let's plan on that. If you feel iffy, just let me know.
I
Okay?
feel iffy.
Not right now. What else do you guys have going on Wednesday and Thursday? Anything big?
I don't know.
Okay.
No idea.
Not of this week. Wednesday and Thursday.
Great. All right, so we have to go back. We have to go back to sine and cosine in order to do secant and cosecant. I mean, clearly, because they're
Yes.
inverses, right?
Very much, yes.
Okay. So I pulled up the sine graph for you over here. So if you look, the one in dark black is just your regular sine graph. So I think a better way for us to even attack this is to look at the critical points. So the sine graph has 3 points where it crosses the x-axis, right? So it has 0, 0, pi 0, and 2 pi 0, right? Okay. Then, halfway between 0 and pi, we have a max and a min, okay? That gives us a strategy for graphing any sine function. Okay, so if you think about it, your original function, so your sine function has critical points at 0, 0, pi over 2 and 1, pi and 0, 3 pi over 2 and negative 1, right? And 2 pi and 0, okay? Those are your critical points of your regular sine graph, okay? So now let's think about it. If I have an amplitude change, okay? If I have an amplitude change, that doesn't show it on this graph, but all you're going to do is pull the max or the min to a different y value, right?
Right.
So we're going to pull this point or this point either up or shrink it down, okay? We're going to pull it up or shrink it down the amount of the a value. So when we have y equals a sine bx minus c plus d. Okay, remember the a is the amplitude, right? Okay, so if I have an a of 2, then I'm going to put my point on y equals 2, right? My max is going to be y equals 2. You don't look like you believe me.
Oh no, I'm good.
Oh, okay. So what that means is when I have an amplitude change, does 0, 0 change? No. I'm still going to go through 0, 0.
Yeah.
Does pi halves and 1 change?
Mm-hmm.
Yes. It now becomes pi half a,
Oh, it is so, yeah.
right? Because I'm just going to move it to the a value.
Thank you.
So you don't, so you're not moving it like from the midline? Are you just moving it?
Well, we haven't put a midline in there yet. So
Okay, so
hold your
that-
horses.
I guess I'm just jumping ahead.
Okay, this is going to really upset me.
Me too. Let me try.
How do I make this so it doesn't like time out? Okay, is my pi 0 gonna change? No.
No, it wouldn't.
So I'm still gonna have pi 0. 3 pi over 2,
Let's see, that would, yes.
yes.
3 pi over 2.
And it's going to be negative a,
Oh, shucked.
right?
Yes.
Because it's going to go down below. And then 2 pi 0, does that change? No. Okay? So when you have an amplitude change, that's what's going to happen. Okay? Now, let's say we have a period change. So now we have a b value, right?
Julie, you have a low battery thing. I don't know if it's.
Oh, on my phone?
Yes.
Well, let's hope it doesn't. It's still going, so we're good. Thank you for telling me. Okay, so now let's have a period change. So we know that the period, we learned this before, right? The period is going to be 2 pi over b, right? Okay. So the period change means that I'm going to either scrunch it together or pull it apart. Okay? So it shows that on this graph. So I still start at 0, 0. I just either stretch it out farther or push it together closer. Okay? So, is 0, 0 going to change?
No.
No. So I'm still going to have 0, 0. Okay, so then if I look at this guy,
X value.
this is going to change.
Is this with no A?
This is, we're going to leave the A in.
Okay.
So like now that we know about the A, it's going to stay there,
Okay.
right? Because that's not going to be different. The period changing doesn't change the amplitude, right?
Right.
Okay, so we're going to leave our A values in there. So now we have to decide about the rest of these guys. Okay? So, you're still going to have, this is going to be a fourth of your period. Okay, so whatever your period is, at 1/4 of your period, you're going to have a maximum, right? Because look at your graph. It's split into 1, 2, 3, 4 pieces. At 1/4 of your period, you're going to have a maximum. Okay? At half of your period, what are you going to have?
0.
You're going to have a 0. At 3/4 of your period, you're going to have a minimum. And at your period, you're going to have another 0.
This makes sense.
Right? So the key to all of these functions is really splitting them into fourths. Because in the sine and the cosine, you have values at fourths. At tangent, you have values at fourths. Okay, so now, what's going to happen if I have a phase shift, which is a left-right shift? So now I have a phase shift.
It will be a
So your phase shift
Where's the track?
is C over B, right? Okay. Is a phase shift going to affect your X value or your Y value? X. So, instead of being at 0, 0, you're going to be at 0 plus your phase shift, right? And that's going to be your new 0. Your new maximum is going to be your previous maximum, so your period divided by 4 plus the phase shift. your new like middle zero, same thing. You're gonna have your middle zero plus the phase shift and a 0. Your minimum is now gonna be 3/4 of the period plus the phase shift and the negative amplitude, or your minimum. And the last one is gonna be your period plus the phase shift and 0. Does that make sense? That's just the right-left shift. Sometimes your phase shift is negative, but that's okay, we can add a negative. That's not a problem. And then we have one more value to do. We have that D value. What does the D value do? It's the midline. It moves your function either up or down. So what value is that going to affect?
Why?
Your Y value. So when you have a vertical shift, which is just your D value, you're going to have your regular X, but you're going to add D to your Y value. Here you're going to have your X and your amplitude plus your D value. Because you're shifting everything either up or down, your D value can be negative. We can add a negative. So then we can keep going. We have P over 2 plus the phase shift, 0 plus D. Three P over 4 plus the phase shift, negative A plus your D value. And this is going to be your period plus your phase shift and 0 plus your D value. So that will graph all of your translations of the sine function.
That's so metal.
So once we graph the sine function, graphing the cosecant becomes super, super easy. Okay. Let me show you what the cosecant looks like, because it looks kind of crazy. Don't freak out. Don't freak out. It just looks a little crazy.
Oh my god.
That's not it. You be quiet. Wait, that's the wrong
Piss
one.
off.
What?
I got a text saying that if I fill out a form for CNCC, I get a free candy bar.
I'll do
Sweet,
it.
you should do that.
But you have to go to Craig to pick it up.
Oh, well, that
That's
sucks.
the
Yes,
expensive
dude.
candy
What's
bar.
the form about?
It's
I think it's just a survey.
it's a survey.
You gotta
about
pay for gas
colleges.
money.
Is it one
Well, I
of
about a
was thinking,
$60
could I have my
fee.
husband pick them up?
Do you want a kiss?
Yes, please.
It's called gingerly.
Can I have one?
Kiss me.
Okay, what I want,
Go to.
Cabbage and drink it.
hot.
Shut up.
Okay, go picture it, kiss your
Not sure what you
Take
guys
your shirt off.
kiss.
You can drink.
Okay, y'all, this
That's crazy.
is the cosecant function.
I can't throw it.
Oh, man.
Because if you think about it, the cosecant
Whoa.
is 1 over the sine. So everywhere that the sine is 0, we have an asymptote,
Oh, goodness gracious.
right? So the sign is 0 at 0, so we have an asymptote. The sign is 0 at pi, so we have an asymptote. The sign is 0 at 2 pi, so we have another asymptote. Okay?
Okay,
So everywhere that the sign is 0, we're gonna have an asymptote.
so that's where cosecant.
How do we know which way it goes?
It always goes the same way. Okay? So what you do to graph the cosecant is you graph the sine function,
Upside down.
and no, this is the sine function just like this. You see my little red sine function?
Oh, I see it.
Right?
Ah.
You mark your asymptotes,
I see
okay?
it.
Then a maximum of the sine function becomes the minimum of the cosecant. The minimum of the cosecant becomes the maximum of the sine, the minimum of the sine becomes the maximum of the cosecant. Okay? It always looks like this. It might be shifted left or right, up or down, but it always looks like
I
this.
need to draw this, okay?
Okay?
This is,
So,
And she said it would be easy.
it is easy.
that is like easy though.
So I'm gonna leave up my
You just grab it.
master key for the sign, right? This is like the master key for the sign.
That is the master.
Okay.
No, God.
Okay.
So you should be a kindergarten teacher.
I would love that. You know,
My
like-
mom
I
would
would love to be in Sienna's class.
I'll
All right.
teach all your kids how to do
My mom will hire you.
So let's do this.
Yes, please
Love
do.
that.
Let's say y equals 2 times the cosecant of pi x over 2. So we're gonna graph that.
Ew.
No, it's not you.
No, that's.
All you're gonna do is you're gonna change cosecant to sine. And you're gonna start by graphing
Pens are dying.
No. You're actually gonna graph y equals 2 times the sine of pi x over 2. You just change the cosecant to the sine.
Oh, and then you just,
Yes. We're gonna graph that first. So, here's my graph. So the first thing I'm gonna do before I even make the tick marks on my graph is I'm gonna figure out what the period is. Okay? So the period is 2 pi over b, which is 2 pi over pi halves, right? So that is 2 pi times 2 over pi. So the period is 4. So now I know that I need to make my scale to 4, right? So here's 0, 1, 2, 3, 4. Okay. My amplitude is 2, so I know I need to go up at least 2 and down 2. I don't have a phase shift or a vertical shift in this one, so I can just ignore that part. Right? So what are my points? Well, I don't have a phase shift or a d value, so 0, 0 is on my graph. Okay. The period divided by 4, so my period, 4 divided by 4 is 1. I don't have a phase shift, I don't have a d value, so 4 over 4 and 2 is my maximum. So 1, 2 is my maximum. Okay. The period divided by 2 So 4 divided by 2, there's no vertical, so 0. So 2, 0 is an x-intercept. 3p over 4. So 3 times 4 over 4. No phase shift, negative a, no d value. So 3, negative 2 is on my graph. And my last 0 is the period, which is 4 and 0. Right? So I'm right here. So here's my, see how easy that was to graph your sine graph? Like,
Easy peasy.
easy peasy.
Until.
Shh, no, there's no until.
No, it's easy.
Come on, girl. There's my sine graph.
Then you had asymptotes.
Okay, where are the asymptotes for my cosecant?
0, 2, and 4.
0, 2, and 4. Because everywhere the sine value is 0, 1 over the sine is undefined, so we have an asymptote. So I have an asymptote right here. I have an asymptote right here. And I have an asymptote right here.
Okay, I see what we're going for.
Okay? So the maximum of the sine graph becomes a minimum of the cosecant. So here's the maximum of the sine. So the cosecant looks like this.
Ooh.
The minimum of the sine becomes the maximum of the cosecant, so it looks like this.
Okay.
The end.
And that's all she wrote.
And that's all she wrote.
Cool.
That's your cosecant graph in blue. So we don't even really have to know how to graph the cosecant. We just need to graph the sine.
Okay.
Okay? Are you good?
Pretty straightforward.
Right?
You good?
You didn't think I could pull it off, did you?
No.
Never doubted you.
No, I
Right,
have
thanks.
trust in you, Miss Julie.
Oh, really?
Even though you're not my friend.
As a coworker.
As a
Colleague.
as a colleague, I have trust in you.
Not a friend though.
You're not my friend.
You've broken my trust as a friend. You've broken my trust as a friend, Miss Julie.
Okay, so there's this one. Okay? Great. Done. So, if we need sine to graph the cosecant, what do you think we need to graph the secant?
We just
Cosine.
did
The cosine.
Because
Because it's the inverse function, right? Okay?
yeah.
Never.
Yeah.
We thought we just did the cosecant.
We just did the cosecant, now we need to do the
We did
secant.
Costco.
We
We
did
did
Costco.
you.
We need
Now
to do
we
the
need to go
secant,
Sicko.
which is 1 over the cosine.
Sicko mode.
Next is
Costco, Secco,
which is
Okay, do you guys have this somewhere?
Costco.
Like with a big star by it?
Oh yeah. Here, let me put a big star by
Big
it.
Star.
Because I'm gonna erase it,
Big star. We made this boy. Very cool shit.
okay? And now we're gonna look at the cosine because we need that for secant. Let me see if I can pull up the regular cosine graph for you, even though I'm sure you know what that looks like.
Right.
Let's pull it up anyway. Here it is.
I could go through the entire one of these.
I don't doubt that.
All right, here's your regular cosine graph in black. So the cosine of 0 is 1, right? The cosine of pi is -1. The cosine of pi halves is 0. This is all from your trig circle. Okay? And the cosine of 2 pi is 1. Okay? So that's our regular cosine graph. Sort of looks like a parabola, but not really, because we know that it keeps repeating. Okay. So let's find our critical points on the cosine graph. Please, while I find it.
Dude, that gave me like a heart attack.
I
So I scooched back at that exact moment.
All right, so here's our cosine graph. Okay, so critical points are like where something important happens, right?
Right.
Okay, so on the cosine, 0, 1 is a critical point. Pi halves and 0 is a critical point, because this is a max, this is a 0. Pi and -1 is a minimum. 3 pi over 2 and 0, and then 2 pi and 1. This gives us an entire period of the cosine. So now we just have to figure out what that means for everything else.
Wonderful.
We were doing that when my boss was in here.
No.
No.
Thanks. I appreciate you not doing that when my boss was in here.
As soon as Watson left, we did it.
We all breathe this out.
Okay, so amplitude change. So amplitude change changes the y value, right?
C.
Okay,
Perhaps.
it does. So the new amplitude change is going to be 0, A,
Okay.
right? Because instead of 1, it's going to be at whatever A is. Pi halves, is that going to change? Do the zeros change when there's an amplitude change?
No.
No, only the max min. So this stays the same. At pi,
-1.
so it's going to be -A,
Yes.
because we're going to pull that minimum down farther. Does the 0 change?
No.
Nope.
Nope.
And then at the period, at the end of the period, 2 pi A, because it goes back up again at the end.
Yes.
Okay. So now let's change the period.
There are the tissues.
Okay. So remember the period changed, we had to divide it into fourths,
Yeah.
right? To get that period to change.
Circle. I must get it.
So this one does not change. Because remember the period still starts at 0 and either stretches out farther or shrinks in closer,
Yeah, so the
And
amplitude.
these are what?
right? So the amplitude is still the amplitude, the period still starts at 0. But now I need 1/4
Of that.
of the period, right? So I need the period divided by 4, and that's going to be a 0.
As we go.
Well, where is the minimum? It's at half of the period. So period, oh my gosh. So the period divided by 2 is the minimum, or the -A value. 3/4 of the period. Oh, it's gone, but is a 0. And the period,
Wait.
Did you write 3 pi? Or
3 pi fourths? Or this is just
Yeah.
3 p? Okay.
thank you.
Pi, P is all same.
No, it's not the same.
No, it's not, Alex. You sinful
And then-
person. Is it just me? 'Cause when I'm trying to write A, it always turns into pi and it looks really wonky. I'm like,
Well.
Pi so much.
All right,
I
so
don't
are
really
you
know.
okay if I combine the phase shift and the vertical shift into the final set
Maybe?
instead of doing it 2 times? So if I have a phase
Chase.
and vertical shift, I would have 0 plus the phase shift A plus the D value, right? I would have period divided by 4 plus the phase shift, 0 plus D. I would have the period divided by 2 plus the phase shift, negative A plus D. And I would have 3P over 4 plus the phase shift, 0 plus D. And I would have the period plus the phase shift. And I would have A plus D. So those are your critical points for cosine. Make sure you have them labeled in your notes that these are for cosine and the previous ones were for sine, because they are not the same. Okay, so this is how you graph cosine. You do the exact same thing to graph secant. You graph the cosine first, and then your minimums for cosine become maximums for secant. Your zeros for cosine become asymptotes for secant. Okay? So, let's see what that looks like. I'm gonna have to keep my business in order here. Okay, maybe an extra day, but I don't wanna split your test over a weekend, so we'll have to figure something out.
Costco,
Well, we could recoup this.
All right, so let's do, this'll be fun. Let's do
Singing a song.
y equals negative 3 times the secant of x over 2.
Do I have a sweater?
So that'll be fun, we'll have a negative,
Free bucks.
okay?
Line measure.
So let me get my graph in here.
It won't fit. Ah.
So I'm gonna start by graphing the cosine. So I'm gonna take this same function and I'm gonna graph y equals negative 3 cosine of x over 2. So before I even fill in my spots by my grid, I'm gonna find the period, because that will tell me what to do with my grid.
Okay.
So the period is 2 pi divided by b, which is 2 pi. My b value is 1/2. So divided by 1/2, which is 2 pi times 2, which is 4 pi. All right, so I'm gonna go, I'm gonna do 1 pi, 2 pi, 3 pi, 4 pi. Then I know I need to go up and down 3 because that's my amplitude. So I'm gonna go 1, 2, 3, negative 1, negative 2, negative 3. All right. I'm gonna get rid of these so I have a little room to work. All right. So my first point, I don't have a phase shift or a vertical shift. So it's just 0, A, right?
Right.
So it's 0, negative 3. Notice that that's opposite of where the cosine usually is, right? The cosine usually starts up here, goes like this. But because we had a negative A value, it's reflected over the x-axis, which we don't even need to know
Okay.
if we use the critical point.
Okay.
Okay? Alright. Feel like I wasted 3 days teaching you the wrong way. But okay, so now we need the period divided by 4. So 4 pi, let me make sure it's here. So we have 0, -3, right? Okay, now the second point is the period divided by 4. So 4 pi divided by 4 and 0 plus d. We don't have a d, so that's my point. So that's pi 0. So here's my 0. Okay? So I need the period divided by 2. So 4 pi divided by 2. And negative a, which is -3.
Okay.
So this is going to be 2 pi +3. So at 2 pi, I have +3. Then here, 3 times 4 pi divided by 4 and 0. Well, the 4's cancel, so I have 3 pi and 0 right here. And then my last one is my period, which is 4 pi and a plus d, which we don't have a d, so a is -3. So 4 pi -3, which is right here, which makes our cosine
Wishy-washy.
look like that. It's not pretty, but we'll call it pretty.
Yes, that's right. This is.
But we were trying to graph the secant.
Oh, I didn't get that. I got a triangle, bro. Oh, jeez.
Wait.
Yeah, no, I drew mine like a triangle.
Please don't. Draw yours like a triangle.
I need to fix that.
All right. So we want the secant. So everywhere that the cosine is 0, there's an asymptote. So there's an asymptote right here. There's an asymptote right here.
Ooh, yeah.
I'm not tall enough. Okay.
Okay, so it's
So now, everywhere that there's a minimum on the cosine is a maximum of the secant. So it goes like this. It goes like this.
Dude,
And it
boy.
goes like this.
Sheesh.
Oh, just like that.
Just
That's it.
Now what about
That is the
Tangent?
movement.
Chase, you know about
I think we'll have to do them
Just
tomorrow.
like
I'm gonna have to
Just
add-
hey,
It's okay.
just
We'll
like that.
figure it
You
out.
see Jed Kirby over here?
Just like
Jed is a perfect example for that.
Okay, so I can't pull these up.
Look what he does. He does that perfect.
Okay? So do you have everything properly labeled in your
Notes.
notes so that you can find what you need?
we'll see.
Is that all?
Okay, well, so let me give you some homework.
Oh no, I was looking at the graph to see if I missed anything.
And then we'll do tangent and cotangent tomorrow. We'll figure it out. If we have to push your.
Don't we know?
We did, but in order to do the cotangent, we need the tangent,
Oh no.
I feel
We
like that
have
was
to
the
go back
hardest.
to hell.
right? Yeah, but I got it now, Alex, and it's like,
That was the hardest for me.
it was the hardest for me too, I'm not gonna lie.
That was not fun.
Let's not lie. Okay, so let's do,
Not a lot.
so on these, it's gonna say sketch 2 periods. You can just sketch 1 period,
Yay.
okay? So let's do page 674. And let's do 21. 27. Sorry, I don't know classes. 29. 31. And how about 33 for a little challenge? So it's really 21 and then 27 through 31 odd. Okay?
Put 31 twice.
I meant 33. You have to do that one twice. I meant 33. Okay? Awesome.
You should stop recording.
Thanks, I should.